Yeah,
We are recording.
nice. So is Casanova a good place to jump in?
For me, yeah.
Okay, cool. Oh, hi Jay.
Oh, hi, Jay.
Hello?
Um,
And
so yeah, go ahead.
I remember, I think you mentioned this other consensus protocol. I don't know the name.
I've talked a little bit about Spectre recently.
Spectre.
Is that the one you're thinking
Well,
of?
I was watching this presentation of, I think the author of this consensus. It's very also, in my mind, it's similar to Casanova. You know, you have this time slots in the first, not round, right? In the first, like first consensus. And then after you fail to get all the order, then you go to the second type of consensus, right? And it's similar is for Casanova. You have time slots, and then if you don't find the order, then you go to the second. I don't want to
Spectre
say
that you're talking about is Spectre the one you're describing?
I'm not sure.
Oh, okay. It's funny because I can't confirm it because I only heard a podcast about Spectre, so I only understand it at a high level. So I actually don't know if there's like time slots or something like that.
Mm. It could also be Hashgraph. They have time slots.
Yeah. And you know, I was thinking that maybe we can differentiate between different consensus algorithms based on these some of these characteristics, right? Are you have the time slots or not in the first part or in the second?
Yeah, I think that's a useful way to distinguish them because I remember like the first one that I really understood well was CBC Casper, and there aren't time slots. And then coming to all these ones that have time slots, it took me a little while to like, first of all, to wrap my head around it. And then second of all, to realize that it's like sort of a norm or something that is, you know, happens in a couple different algorithms.
Yeah. Because I mean, the classification would be asynchronous versus semi-synchronous BFT, and you know, you can't have a guarantee on liveness if you have legitimate asynchrony, like in CBC Casper. So, you know, in any normal TCP network that where the actual message sending is asynchronous, you usually try to, in practicality, try to make some kind of semi-synchrony.
That's the first time I'm making that connection that like being totally asynchronous is what allows us to not have any notion of time slots. Just make a block whenever you want. And that was CBC's Casper's strength, that you can make a block anytime you want. But then also, like as the Pyrofex people pointed out, and you just said, that's why we don't have the like proof of liveness. Okay,
but
cool.
There's different notions of synchrony constraint, right? If you have the time slots, then you need some kind of. You're saying I have some kind of wall clock in front, right? I'm maintaining some kind of synchronization of this clock between all the participants, right? Mm-hmm. Which Greg was saying it's like it's a big problem. So in Casper, you can do it like differently without wall clock. My understanding is that this is what we want from consensus. I see these time slots as a problematic, right? So I'm not sure if this is like really.
But true. I don't know if you necessarily have to have it be wall clock in order to be semi-synchronous. Because I think even like Grandpa, I don't know if they use wall clock or some global clock, or if it's like a relative thing based on like where the round started. You can compute like 4T from the start of the round. I think there's different methods of doing it.
I'm thinking especially about time slots, not about asynchronous and synchronous. I'm not sure if you have concrete time slots. Can you do it without wall clock? That's my question.
I remember seeing, I don't think this is implemented, but I remember seeing something in one of the like parody documents about what they were going to build or hoping to build where you don't have to assume a perfectly synchronized clock where like the different validators can, you know, maybe my clock is 3 seconds ahead of yours and 2 seconds behind Jay's or whatever. Like they're a little bit out of sync. but based on when I'm seeing these blocks come in after a couple rounds, I can get a sense of like, oh, here's basically where my clock stacks up against everybody else's, and get some like, I almost want to use the word like feedback, about how your clocks are doing to kind of help them. But it did assume that the clocks were processing at the same rate. Like mine might be offset from yours, but it can't be running faster than yours, where I'm like constantly getting further and further ahead.
Yeah, I remember this guy from CashGraph. He was talking about that. You don't have to have completely synchronous, but yeah.
Yeah.
Hi, Isaac.
Hey, what's up?
Hey, Isaac.
Hey.
How you doing, guys?
Good. Okay, well, the part about Casanova that I wanted to talk about was the part that I never understood. Do you want me to show the paper?
Sure.
All right. Oh, yeah, and this is it. But wow, that's pretty tiny. There we go. So section 2.2 was the part that I always sort of struggled with. Basically, I just never really got it. But then I had this email exchange with Mike and Kyle about it. So he says, we assume some set of all possible events, this like big E. And that part, I think, is pretty clear. Like if we think of a cryptocurrency, like there's all these different payments I can make, whether it's, like the reduce my balance kind, or the like consume these UTXOs kind.
Like all possible transitions or something, right?
Yeah, I've been liking to call them transitions. And then later he basically says they're similar to transactions.
Right.
Yeah. So that part I think is pretty clear. And then here's where I started to get a little confused. So he says we assume that E is suitably partitioned into mutually exclusive alternatives, so that like the big E is made up of all of these little E's, and then there's some indexing set, which I think it's without loss of generality, maybe we can say those are like the natural numbers. But I'm not certain about that part. So he says, that is, each one of these little E's, each one of these like spends that I could have, or whatever our notion of like, transition is, belongs to exactly one of the alternatives. And I don't think the word is in this paper, but when Kyle and Mike were talking about it, they used the term conflict domain quite a bit.
Yeah.
Yeah. Like the intuition that I'm starting to build is that like, we can split up all these events into conflict domains and say like, okay, there's jillions of them out there, but like, here's one domain that has 15 events in them, and these ones can conflict. These 15 can conflict. And so we only ever want to see at most one of these 15 in the final block tag. And further, these 15 cannot possibly conflict with anything in any other conflict domain that's out there. Or that's and I should be clear, that's like my working understanding. That might not be correct. Yeah.
So, okay, so we're saying that these are partitioned into these mutually exclusive alternatives or conflict domains or whatever. How do we I don't know. I guess for me, I'm just wondering, like, how do I decide if a transaction is in some particular E sub I or something like that? Like, how do I know where the transitions or the transactions fall in terms of these domains?
Yeah. So all they said in the paper is this part that I highlighted, which is like, we have some function, some index function that given one of the transactions, it'll tell us, it'll basically tell us like which of the conflict domains it's in.
Yeah.
But I think I have an example actually, because they were talking specifically about C Delta, which was their attempt at a cryptocurrency that uses this.
Yeah.
And
cool.
Well, okay. So basically, like they said, it wasn't even here. There's this other write-up. Let me show this one real quick. I think it'll be in my history.
And what is the relation between two different conflict domains?
The relationship between two different conflict domains?
They're disjoint.
They're disjoint.
Yeah. Yeah.
And that's it, right? I mean, obviously they're all subsets of that big E. But other than that, they're just disjoint, I think.
Oh, so you are choosing some some part of this index, right?
Yeah, I think that's right. So the idea is basically like this DAG is forming. Here we are watching it and helping create it, but any individual validator is primarily watching it be formed. And like, okay, so we see some event come across, and so we run that index function and say like, okay, this event was from index 600. Do I have any other events from index 600? And if so, now it's time to boot up the like decision making mechanism.
Okay, so that's how they're going to detect their double spends is like two transactions in, or potentially conflicting transactions is they just happen to be in this same conflict domain. Yeah, that makes sense, I guess.
Yeah, I think that's right.
Can we say that this is like a block? I mean, you have a bunch of transactions.
Mm-hmm. Yeah.
Oh, it probably has no relation to time though, other than it has those transactions in it. But maybe, I don't know.
Yeah. How do you define an index?
Yeah, that's a good question. I was trying to get that page to load because there was something in there, but that's okay. So all they really said is like for some indexing set I. That's why I was saying like I think we could just take them to be integers, but like I don't really know that. But okay, so well let me just say this. So like my understanding of C Delta, their cryptocurrency, is that they've defined the conflict domains to be it's like it needs it's a tuple basically, like when one of them is a key or like an identity, right? So like my public key or my address or whatever, and like a nonce or like a sequential. Kyle said like think of it as a check number if that helps. So like every time I make a transaction, obviously I'm going to sign it with my key, and I'm going to have this sequential nonce. And so if you ever see two transactions that come from my key with the same nonce, we have a conflict and we have to decide which one comes next.
So this key for this set of E is this tuple, right? What you're saying.
Yeah. So I'm thinking like in this case, the little i's are that tuple, like my key and my nonce.
Yeah.
So if that makes this function like pretty simple, right? If I send you a transaction that says like, here's my key, here's my nonce, here's what UTXOs I'm consuming, and here's what UTXOs I'm creating, like the I was just the first two elements of that transaction. Mm-hmm. So in that case, it's pretty easy to compute I. Yeah. Okay. So yeah.
I was just going to say, I think like given this setup, like, okay, it would be pretty easy to calculate that index for a given transaction or something, but to try and think of how the setup is actually created is kind of the difficult part for me. And I guess you're saying they use this idea of conflict domains and C Delta, which maybe I'm not very familiar with what they did there, but that would be cool to see that.
Yeah, I'm not too familiar with it either. I read their white paper, but unlike this, their white paper for C Delta was not very technical. There was a lot of like...
Yeah, I think I looked at it, yeah.
Yeah.
I feel like there was some history of money stuff in it, maybe.
Oh, yeah, maybe. I don't remember. I only read it once.
Okay.
Yeah. Okay, so like basically my understanding was that if you start with something like Bitcoin, where you have all these UTXOs and a transaction consumes some and creates some new ones, they're making this restriction. They're saying, well, first of all, like Bitcoin has this whole stack language that allows you to do multi-sigs and stuff like that. And they're saying like, throw all of that away. The only way you can spend a UTXO is the simplest way, which is you produce one signature from one key that spends the UTXO. Mm-hmm. And then the further restriction that they're making is saying a transaction can only consume UTXOs that all come from the same key. So there can't be these ones where like I have, 3 different keys and 3 different UTXOs, one to each key, and I'm ready to spend them all, so I consume all of them in a single transaction. I have to have this like stronger notion of identity. And so like, which is a key. And so I can only spend UTXOs from this one single key in a given transaction.
Interesting.
And so I think that helps us build up the conflict domains because one way you can have a conflict is like, Well, I almost wonder if I should try to show this other. So I maybe their website is down, but oh, let me just find this document. This. So this is the email exchange that I had with those guys. And somewhere in here, I put a link. I didn't realize how crappy this thing was going to look when it. I can't find it. Darn it. That's too bad. I thought I put a link in here to this diagram. Okay. That's okay. Bear with me for a second. I'll just draw a new one. Page. Okay. So like if you would just imagine a couple transactions here and they have some outputs. And then I had drawn things like this and I called these transactions, oh no, sorry, I did that wrong. Let's continue from here. I think I can get it right this time. There were some double spends. So when the line forks, remember that's a double spend. Because that's two transactions trying to consume the same output. Okay. So then we called these A, B, and C. So A and B conflict because of this, and B and C conflict because of this. And that article that I was trying to show on the PyroFX website, one of the things that they said was within a conflict domain, conflicts are transitive. So like if transactions A and B conflict and B and C conflict, then transitive means A and C have to conflict. And so I drew this diagram, not counting the top part that's irrelevant, but like this part. I was like, well, this is a pretty good example of where transitive doesn't work. And even if all these UTXOs, like even if every single one in the same diagram all belonged to Alice, A and C still don't conflict. And so that's when they were saying like that's why we have to order the transactions with a given key. Because like let's say every transaction in here comes from the same key, then we have to put a nonce on it. So like let's say A's nonce was 32, and this is really actually still confusing. Let's just try that. If we put those nonces on there, I don't know. Yeah, go ahead.
You're saying A, B, and C are all really the same person, maybe with 3 different identities or something.
So in this case, what I'm trying to say is that all of the UTXOs, which are not the boxes, but the lines that connect boxes, belong to the same person. And then,
right.
Yeah. And then also like, I wasn't saying this originally because I didn't realize that they had that requirement that every UTXO in a transaction has to be spent by the same person. But then I was like, okay, fine. So let's say like every UTXO and every transaction in this whole diagram all belongs to Alice.
Yeah.
And then I was saying like, how does that make the conflicts transitive? So like,
where's the difference if this is like only one person or you have multiple? I mean, you differentiated these transactions with nonce, so you can see it as a identity, right? Every transaction is separate identity.
Yeah, but the only way he was able to do that was because they have the same key. That's how you can give them each a sequential nonce. If they were 2 different keys, then it might be like 32, 33, 10 or something. But you couldn't even compare those because it'd be totally unrelated. Because the index is the key and the nonce, not just the nonce.
Okay. So nonce is like giving you ordering. I was thinking that, I was not sure how you get to the order. Yeah. Okay.
Yeah, one thing that Mike said is that we are totally ordering the transactions within a given conflict domain or something like that. What did he say? Because at first I was thinking only one transaction per conflict domain could ever exist. So let's see. So Mike says, we didn't say so explicitly, but Bitcoin's UTXO model fails to be transitive. Okay, that's the diagram that I had drawn right there.
Mm-hmm.
The point of the transaction domains is to make it easy to identify situations where we know that transactions cannot conflict. So I think the idea there was like a transaction that comes from me and a transaction that comes from Jay can't possibly conflict because they don't even have the same key. And that means they can't possibly consume any of the same UTXOs.
Mm-hmm.
Because we have that restriction that a transaction has to only consume UTXOs from a single key.
Yeah, that makes sense.
So he says the EVM and Bitcoin have effectively a single conflict domain. In that sense, they're both compatible with Casanova, but systems where conflicts are transitive can take better advantage of the concurrency.
Wait, sorry, what was that restriction one more time?
Which one that I just read from here?
Yeah, about UTXO inputs have to come from the same key.
Yeah, that's right. So like, if this were Bitcoin, you know, maybe this first UTXO could belong to Alice, and the second one to Bob, and the third one to Charlie, and the last one to Dave. And then if you look at like transaction B here, the box B, it consumes a UTXO that belongs to Bob and a different one that belongs to Charlie.
Right.
Yeah. So this is within a conflict domain. All UTXOs can only be self-transactions.
That's a good question. So he says, let's see, what did he say? The point of the transaction domains is to make it easy to identify situations where we know that transactions cannot conflict.
Mm-hmm.
Yeah, so I took that.
Yeah.
So, okay, here's how I'm taking it that might be wrong. Like, we want to partition these in some way that's useful, that shows us, like, for the vast majority of them, there's no way they could possibly conflict, so we don't have to bother, like, seeing whether they conflict or choosing which one is the real one.
Mm-hmm.
And one way that they figured out to do that was to add this restriction that these sort of like mixed UTX or mixed transactions that spend UTXOs from more than one key, if we disable those, if we disallow those, then it's easy to make your conflict domains the way we said, where I is that tuple of like key nonce.
Mm-hmm.
Yeah.
So that's just not allowed in general. It's not just in partitioning the conflict domains.
Yeah, that's right. That's right.
Okay.
Or you know, again, that's my current understanding.
Yeah. So basically, like this diagram with that UTXO from B and that UTXO from C going into block B, that's just not possible at all in Casanova, right?
Right. That's right.
Okay.
But are they saying that they will choose A and C in one conflict domain and then put B in another conflict domain?
Well, no, I think they're saying like we need to be able to partition these into conflict domains, and you know, A fits nicely into a conflict domain. It's Bob's because it spends a Bob UTXO, and C also fits nicely. It's Charlie's because it spends a Charlie UTXO. But transaction B, that doesn't even fit into one of our conflict domains because it spends from two different keys. So instead of like trying to find some different, more subtle way to partition our conflict domains, let's just disallow those mixed transactions entirely. And now we can partition them.
You've said it like 10 times already, but basically the indexing is the key in the nonce. That makes sense. So you can tell like where these UTXOs are coming from, and that's what is essentially determining your conflict domains.
Yeah,
that totally makes sense.
What if B doesn't come from C? So like A and B are double sign on this like B link, and then what if like B was included in the conflict domain of C? Then how do you choose? And A is in a separate conflict domain. Then how do you choose between this conflict domain with A and the conflict domain with B and C?
Yeah. Okay. So Amar, you're talking about the blocks labeled A, B, and C, or the UTXOs?
The blocks. So one conflict domain contains just A, and then the other conflict domain contains B and C, and we don't. So then how do we choose between those two conflict domains? Because we're double signing on the UTXOV.
Oh, I see. Okay. So like you're saying if we're, oh, wait, okay. So in order to put them in different conflict domains, so if A wants to go in a conflict domain, so A's conflict domain, I think they did it like this or something like that. That script E of block A, its conflict domain is going to be like whatever key it is, some key and then a nonce, which is 32. And then to get B in another one, then we would have like its key, whatever it is, and 33. So like to get B and C in the same, here's what I'm trying to get to get B and C into the same conflict domain, or to get any two transactions into the same conflict domain, they have to be signed with the same key and have the same nonce. So that's how we decide.
Okay, so each conflict domain only has one, there's one key per conflict domain, or that's the, okay, limitation?
That's my understanding. That's the idea I'm trying on for size, but I'm still struggling because like imagine if we change this block B to be oh yeah, no, we don't even have to change it. Like it's still 33. Here's what I'm confused about, basically. So this block A with nonce 32 and B with nonce 33, like it seems like those should be in different conflict domains, right? Because they have a different, even if they have the same key, they have different nonces. But yet they definitely still conflict because they both consume that same UTXO. So maybe there's something I'm not getting quite right about this still.
So,
like you're calling.
oh yeah, go ahead.
Calling not where you don't have a conflict. The transactions where you don't have a conflict, you're calling a conflict domain, and you know, I don't know. It seems like rather than them containing a conflict domain, seems to exclude any conflicts by what you're saying, right?
But how do you order the conflict domains then?
Oh, how do you order it?
Like, because if you had A and B in separate conflict domains, then like I feel like they would have to be in separate conflict domains. And which one goes first?
Yeah, the way I've described it by saying the conflict domain is determined by the key and nonce, then yeah, they definitely have to be in separate ones because I gave them separate nonces. Yeah, so okay, so there's definitely something, one little piece of this at least is not quite right still so far.
Well, so yeah, so I'm trying to think about with the conflict domains, do we want to be adding transactions to the same conflict domain that do conflict and then try to resolve those conflicting transactions, or do we want to be adding kind of like evolving the conflict domains with transactions that don't conflict, and we know they're all good if we just at least stay in this one cone or whatever, and then if we maybe try to go outside of that, we have issues. And I know we're sort of jumping between like the abstract presentation in the Casanova paper and kind of the concrete C delta implementation.
Yeah, I'm pretty comfortable with that though.
Yeah, and that's totally fine. I'm just trying to understand like what the whole point of the conflict domains are. Like, is it a place to like gather up all of these potentially conflicting events, or is it a place to like gather all of these like very clearly not conflicting events, and then we can like work with those pieces? I don't know. Is that question clear?
Yeah.
It's clear,
and how are we have some kind of batch of transactions that we put in this conflict domain, and then we confirm somehow, like a finalized block here.
Yeah.
This is like an open domain that you put some other transactions later, or
Let's see. So one thing is like there's a difference between having seen a transaction on the network that someone's actually trying to like submit and just being able to conceive of such a transaction, right? Like I can imagine someone trying to spend some Bitcoins without them having actually submitted that to the gossip network and like it arrived at my Ethernet port. And I think they're trying to partition potential events. not like just the ones that we've seen so far, but like
Yeah.
my understanding was that like any event you can imagine, whether you've seen it or not, belongs to one of these conflict domains.
Yeah, and that's why they partition the entire set of all possible events. That makes sense.
Yeah. So he says, okay, so that is for each possible event little e in this set of all possible events, each event belongs to exactly one conflict domain.
Oh.
Yeah, so I think it has
next
to be,
part.
Oh yeah, what was
And
that?
at most one such event could have occurred.
Right.
Does that mean that each one of these partitions should have only one transaction in it?
I think it means that like EI itself might contain multiple of these hypothetical transactions that could have happened.
Okay.
But we're only I think could have occurred means like we've allowed it to reside permanently in the DAG. Like we're counting it as, we're reaching consensus over it.
So how do you have two events with the same index I? Like how do you have two events in one of these conflict domains or epsilons?
Yeah. So if my understanding, yeah, go ahead.
I mean, you said with the same key and with the same numbers, right?
Right.
Wouldn't that be a conflict? Like a double spend or something is the only way you could have the same nonce and the same key?
Yeah, a double spend definitely is one way to do it. And I think even like if you're just like not using the network properly, maybe because you have buggy software or whatever, you could have like two transactions that like really based on the UTXO model should be valid. Like maybe I own two UTXOs and in one of them I try to one transaction I spend the first one, another transaction I spend the second one. Like at a transaction level, those shouldn't conflict. But if I've signed them with the same key and given them the same nonce, then that puts them into the same conflict domain. And Casanova is going to have to decide like which one is the real one.
Mm. But you could just as easily double spend with a different index, like 2 and 3, and still.
That's what I'm stuck on. I feel like that's what we illustrated here, right?
But
like
is this? But you said this is like ordering. So in that case, this is not a double spend.
Oh, that's right, Thomas. Yeah.
And you have A, and then you spend B. Right. This seems like a completely valid.
I mean, what if you spend like you only have 10 units and you spend 10 units twice, and based on the partial information of the network, both clients don't see the other transaction yet.
You mean in different conflict domains?
Yeah, they would be in different conflict domains because like the nonce would be like 2 and 3.
Yeah. I have the same question.
Yeah. Yeah.
Yeah, this is like an ordering between different conflict domains, right? What Amar was asking also.
What was the question then?
How do you know ordering between different conflict domains? Oh, you're not.
Well, the whole point is you don't need to know ordering between different, like you need to know the ordering within. I'm not really clear actually, but I think at some point one of the big ideas is that like in general, because this is DAG based, right? We don't want to establish total ordering definitely, and we're trying to set up these domains in such a way that we never need to know which happened first between two events from different domains.
But I'm not sure if we need, maybe we don't need total ordering of all transactions, but we need some ordering of all the conflict domains, right? Because
you mean you want to be able to, are you saying you want to be able to order transactions across conflict domains, or are you saying you want to be able to order the conflict domains themselves?
Conflict domains themselves.
Oh, okay. Why do you want to order those?
Because you could.
I mean, yeah. You somehow must say this is the final ordering of conflict domains, and this is how this account was. This is the balance of this account.
Yeah, because there's still like a sequence, like a story to how you're like you have to receive transactions and then spend them, in that ordering, even though they're not conflicting,
Oh.
they're still a sequence.
Yeah, like if Alice pays Bob some money or whatever, and then Bob goes and pays Charlie, like we need to know that Bob got paid before he spent that money, I guess.
Oh.
Yeah, exactly.
So we need those conflict domains ordered in some way. That kind of
No, wait, that doesn't mean we want to order I agree that we want to do the thing you described, but I don't
Yeah.
think that is ordering the conflict domains. That's ordering
Okay.
transactions still across conflict.
Yeah.
Right?
Yeah,
Like,
so that's still like DAG level, basically.
yeah.
Okay.
Yeah.
Like, I don't need to know
How-
that
what
Slav with nonce 6 comes before Amar with nonce 30 as conflict domains themselves, right?
Yeah, I guess that's true because,
So what is the way of getting this total order of transactions? Is this nonce like order?
Yeah. Yeah, I mean, that's a good question.
Because I don't know, I'm not sure how this nonce is generated, but what if I publish some nonce that came later, and then after a week I publish number one?
You mean like if you issue your nonces out of order, like two perfectly valid transactions, but you publish the high nonce one first, and then later go back and publish the low nonce one?
Yeah.
Yeah.
I mean, like on Ethereum, you can't, once the block has been like finalized and you're building on top of a block, you can't post a nonce for an earlier, like you can't post an earlier nonce.
Oh.
So it's almost like an ordering is decided once there's finality.
interesting. So your nonces have to be monotone, increasing.
Yeah, and that doesn't mean that if you see one, it's necessarily a bad practice or a double spend. It's just that you want to accept ones that have been, once they're finalized, then you can't go backwards.
Oh.
So it doesn't mean malice necessarily, but it definitely means that that older, lower nonce one's not going in the chain.
Yeah.
I think in this spectrum consensus, they're saying that you need to publish new block in this specific time periods, right? But there is also some way to say how long in the past you can post something, you can add something to block. So this is somehow defined.
Yeah.
What is finalized, right? This is you want to know if this is, do you publish this on something that is already finalized or not?
Mm-hmm. Yeah. Does Casanova have a concept of finality?
That's a good question.
I think I remember they did.
Yeah, I thought I remembered that too. I'm not too familiar with how to use my search feature on here, apparently.
Is Casanova a consensus algorithm, or is it this kind of?
Yeah.
Okay.
Yeah. So what we've kind of been blurring together today so far is Casanova, which is the pure consensus algorithm, and C Delta, which is a cryptocurrency built with Casanova as the or designed, I guess. I don't think anyone ever built it.
Okay, so C Delta is the one with this concept of conflict domains?
That's right. No, Casanova is. So this paper on the screen now is Casanova.
Okay, yeah.
It has the conflict domains, and then because C Delta uses Casanova, it inherits the same concept. Yeah.
Gotcha.
You think C Delta stands for conflict domain?
Oh, maybe it does. I don't know. Yeah. Okay, I had an idea just now. So I think this diagram might be totally fine, and that it was correct to say that this part, that the conflict domains are made from this tuple of key nonce. And so the transitions box A and B here are indeed in different conflict domains, right? Because they have different nonces.
Mm-hmm.
And so since transition B came later, it's nonces 33, or I should say came with a higher nonce, right? So let's say like A goes into the DAG with nonce 32 and then B goes later with nonce 33. B can be determined to be an invalid transaction on its own, not because it conflicts with anything else in its domain necessarily, but because it tries to spend a UTXO that doesn't even exist by the time we get to nonce 33. Because transaction A already consumed that UTXO.
Yeah, again with that concept of finality, if everybody can agree that A happened, and if not, then some people think B happened and some people think A happened, then you reach a conflict.
Mm-hmm.
But you have ordering of nonce, so
Yeah.
right. You cannot say that B happened without A. But can you just choose and discard B and say, okay, I will choose A, and later I will try to confirm B.
Is each conflict domain a block too, or are there multiple conflict domains in each block? Because the paper still has this concept of a block.
What is a block?
It said like a round is defined as a fixed number of blocks.
Amar, do you want to share the part of the paper you're looking at?
Yeah, I'm in section 5. Yeah, I can do that. Figure that out. Share screen. Is this something like this?
That sounds right. Yeah, perfect.
Yeah.
Ooh, all your keys. All right.
Yeah, so I was just looking, like, we assume that validators produce a block every minute. I was just kind of skimming and I just noticed this concept of a block. I didn't really go deep into it because I was also listening to the conversation. But yeah, I'm trying to think, like, I feel as if based on our discussion, we have to order conflict domains so that, like, if A is in one conflict domain and B is another conflict domain, then like B is invalidated by the fact that A was like finalized, I guess. But I'm not really sure if we're ordering them, then that's kind of like just a normal blockchain, and the conflict domains are just like blocks. And then that's not really anything different. So you can go back to sharing. There wasn't really anything else.
Oh, sure. Okay. Cool. Yeah.
So remind me where the nonce is coming from and like what the point of the nonce is, because I feel like that was a different that was an aspect that I hadn't seen before in this Casanova business.
Yeah, nonce is not part of Casanova. Casanova only insists on conflict domains, and then the nonce is an implementation detail of C delta that somehow allows them to meet the assumptions of conflict domains.
Yeah.
So there is some constraint in the ordering. Sorry. Right? For this nonce. You cannot order transactions by nonce if you don't know anything about it.
Well, that's kind of what I was getting at, is like how is that nonce generated, and like what relation does it have to anything else that's going on in the network?
It's generated sequentially by each participant, each user.
Okay.
Yeah, or each key, I guess, not like human necessarily. Yeah.
Okay.
Yeah. And actually, I don't know if it's sequentially or if it's just monotonic increasing.
Yeah.
So let's see, like, I really wish that these would text wrap, because there was a lot of good information in here, but it's like so hard to read. So let's just skip to Mike's last thing, because there were some good tidbits in here. And in fact, I'm going to do this. Oh, damn it. I'm going to copy it into like a text editor. Okay. How's that for reading?
Oh, you gotta share your screen.
Okay.
Oh, son of a gun. I wasn't sharing my screen.
It probably looks great though.
Yeah. All right.
Oh yeah, much better.
That's good.
Okay. All right, cool. So the levels of indentation are Mike, then me, then Mike. So this seems relevant. Yeah, okay. So I think that part that I highlighted, I guess, makes it clear that it's within a single conflict domain where you could have conflicts. And for some reason that I'm still not really clear on, they're insisting that conflicts be transitive within those domains.
Yeah, because I thought the point of a conflict domain is that it was like the set of all transactions that do conflict.
Yeah, right. Yeah, I think that's right.
So then transitive would just make sense by the property that any two transactions conflict.
Yeah, that's true. You're right. Yeah. Okay, so then he says like, so, oh yeah, so here he says you also have to totally order spends by a given key. Merely adding the restriction that UTXOs are owned by a single key doesn't suffice. Although I think that he's saying that is something they do, but it's necessary but not sufficient. You also have to totally order spends by that key. The owner of UTOs X and Y has to choose an order for the transactions A, B, and C. If she issues A or C first, then she can't issue B. This is the same diagram that was on the other screen. Since one of the input UTXOs has been spent. Okay, so that's important. So he says if she issues A or C first, then she can't issue B.
Okay, this is like this means that you have you have A and then B, right? If you have enough balance to do the B.
Well, I don't think you can ever do A and B because they consume the same UTXO.
Oh, you mean in the case that B is using the both of these, B and C? Right?
This is the exact diagram that I sent to Stay. In fact, let me.
Yeah.
I called these X and Y, and I did not label the UTXOs. So, whoops. So now it's the exact same diagram. So he was saying, he was saying like, if the user issues A or C first, I think first there means like with a lower nonce maybe. Yeah. So okay, I feel like I'm getting this. I think the idea is like if you have the same key and same nonce, we're putting those in the same conflict domain, and therefore like by definition they conflict. Even if they don't necessarily have to conflict. Like if I put the same nonce on A and C, this is the part that was confusing me. Like just by the UTXO model, A and C don't have to conflict, right? Because they don't have any of the same common inputs.
Yeah.
But if we issue them with the same nonce and same key, that puts them in the same conflict domain. And now Casanova is going to force us to decide between one. So like if you want both A and C to go in, oh, that makes perfect sense. You can still have A and C, but you just have to put them with different nonces. So like, let's say we put in A with some particular nonce 32, and then we put in B with a higher nonce 33. Those are not in the same conflict domain because they don't have the same tuple here, the same key nonce tuple. So they don't conflict in that sense. But B is just individually on its own invalid because that UTXO doesn't exist anymore because A consumed it. But then Jay still had the point of like, what if there's some validator that didn't see A yet?
Yeah.
So I guess like now I'm speculating definitely. If we insist that the nonce increase sequentially, not just monotonically, then like if a validator sees B arrive with nonce 33, then they can say like, oh well, I haven't yet seen nonce 32 for that particular key.
Yeah, and I mean, I don't even think you need to go that far. I think, well, you could accept it as a block, and as it tries to reach finality, it comes in conflict with this A that's also trying to reach finality, and then the proof comes out that it's a double spend, and A has an earlier nonce than B.
Oh yeah, okay.
So yeah, it's just like a property of the consensus algorithm that eventually any double spend with a different nonce will be notice and probably you can probably choose which one is the right one.
Yeah.
But this is like a problem, right? Because what if you want make like 1,000 transactions from one UTXO?
With different nonces or same nonce?
No, with different nonces. It's like completely different transactions. But what?
And send them to 1,000 different nodes, or
yeah, I'm imagining that you need to wait to finalize this previous one, so you issue next one because you don't want to have conflicts, right? Because latency on the network or something.
Wait, you said these are all double spins and they all have different nonces?
Well, they will be in the same situation as A and B. Right?
Yeah. So let me see if I am getting this right, Tomislav. You're saying we do something like just a whole bunch of these that all consume.
Yeah, exactly.
Yeah,
exactly.
And their nonces are different, right? One, two.
Yeah. And you have enough balance to pay them all, and everything is fine.
Well, there's no enough balance to pay them all. Because they're not just trying to pay for my balance. They're trying to pay specifically from this single UTXO that comes out of X.
Mm-hmm.
Mm-hmm.
Right? Even if I own a bunch of other UTXOs that have a sufficient number of tokens, I'm not trying to spend those tokens. I'm trying to spend like this token right here.
Yeah.
What if that's like 10,000 tokens and each one of these are like 100?
If that's a 10,000 token UTXO, then each of A, B, C, and D is trying to spend all 10,000 tokens because they're consuming that UTXO.
Oh,
yeah, they would have to be ordered, like A goes to B, B goes to C.
Right.
But you are giving the order. You are giving the order 1, 2, 3, 4. But this is like
by the nonce. That's not the same kind of ordering. I don't think the nonce has like any relation really to the UTXO part. It's more of just like a way to help reach consensus.
So in this situation, you must really wait to A to finish to deploy B.
Well,
go ahead.
I was just going to say, if you can sign A and like complete that transaction, or like the data for that transaction, you don't have to wait till it reaches finality. You could create B based on the hash to A. That was all I was going to say.
Yeah. So Jay, you're imagining it in a different scenario now where we do like, here's X and then like, here's A, and it, maybe these 4 transactions here are like me trying to pay 4 different people. So from A, I send a little bit off to somewhere and then I use the leftovers. And from B, I send the rest off to somewhere and then use the leftovers, like that kind of thing.
Mm-hmm. Yeah. You don't have to wait for finality for each one.
Yeah, totally. So I agree. Like if you have one big UTXO coming out of X and you want to divide it up, you can totally compute all of this offline and submit it all at the same time. And that should be valid. But this thing that we drew on the right is a different situation than on the left, where they're all spending that same one UTXO.
Yeah.
So I'm curious, like if we're in the left situation where we do have this quadruple spend, and we like send them all out in reverse order, for example, like maybe I send out D and wait a while and send out C. I'm curious how that works. Or I guess what I'm curious about, I guess that's the same thing as like, do the nonces have to be sequential? If they don't have to be sequential, we could get finality over D. And then like, I don't know, C comes out and then with a lower nonce, but double spending something that was already finalized.
But what if C is somehow rejected? Like become an orphan? How you will finalize D? Is this possible?
That's a good question.
Maybe that gets into the difference here between the UTXO and the block in Casanova. A block could become orphan, but a UTXO, you couldn't. I don't know if you could have D. Actually, yeah, I don't know. I'm not sure. It's interesting.
You mean is it possible to have this transaction inside the finalized block, right?
Which transaction?
This invalid somehow.
Or even like, is it possible to have 2 from the last, like a previous block, and then 4 in the next one without having 3 in between? Probably not. I'm not sure. That's kind of up to the Casanova spec.
Yeah, I'm starting to lean toward like they must have to be sequential. Like the nonces must have to be sequential because otherwise you have this weird problem of like issuing something with a really high nonce and then going back and later issuing something with a lower nonce.
Yeah. Yeah, I'm just imagining this horrible attack on somebody's wallet where you issue a transaction with the highest nonce and they can never spend anything again.
That's an interesting concept.
You just need to screw up this one transaction, right?
Yeah. Yeah, there's like an overflow in the network. If you do -1, then your account's done.
Yeah.
Oh yeah, that's actually a really good point, Jay. Like if we don't require, in Ethereum, do nonces, they just have to be monotonic, right?
I'm not sure now that I think about it. I know that, yeah, you can definitely just submit a high transaction. I do that in test nets all the time.
So, yeah, just with the super high nonce.
Yeah, just when you want to be sure because there's a whole bunch of random stuff going on.
Oh, yeah. Oh, so you're just jumping way up because you don't know what's out there and what's in and what's not.
Yeah, exactly.
Yeah. How are the nonces stored? Are they just like fixed width integers?
Yeah, they're just integer
so there's
numbers.
Such a concept as max nonce, and then after that you have to get a new key, I guess, right?
I'm not totally sure, but that seems logical.
And you have to make sure that all of your assets are safely under the control of the new key in sufficient time.
Yeah, I mean, it's a super high number, but
yeah.
If you ever just like messed up and threw something out there.
Right.
Yeah, it's dangerous.
Yeah, I'm thinking of some attack where like, you leave your laptop unattended for a really short amount of time. Definitely not like to go to the bathroom or whatever. Definitely not enough time for me to steal all your stuff, but just enough time to issue a single transaction with like max int as the nonce, and then your account's
Yeah.
Just like fork bombing your friend's computer. Like you don't gain any benefit from that.
Right. Yeah. Oh yeah, I mean actually like so if one of the things that your account has control of is like the ability to vote in an election, bricking their account like that would be a way to like censor their vote or something.
Yeah.
Cool. All right.
What if validator decides to skip this one your transaction?
Someone censors my censorship attempt. Do you guys want to switch to computational calculi, or does anybody have anything to share in that section?
I want to just ask about blocks. Can we understand completely Casanova without understanding how they're collecting this inside the blocks and how the blocks are ordered?
Yeah, that's a good question. I know for sure there's a difference between the transaction DAG that I was drawing versus like the actual block DAG. I don't know the answer to your question, whether we can understand it without looking into the block DAG structure. Definitely their conflict exclusion part, we need to know the block DAG structure because it comes back to like which block is higher up or like further back in the DAG. So.
Isaac, do you have some stuff for?
I'm trying to think of what I would show. I mean, I've been working on things. I'm just nothing is like really jumping out in my mind to show. I've been like transitioning to working on a different machine, so that's been like a lot of my time, unfortunately.
I have some old questions about.
Oh, you have old questions. All right.
Yeah. About pigs.
Oh yeah, okay.
I'm not completely sure about your answer on this, because I didn't want to, go into details.
Yeah.
No, I'm not sure. What do you mean by peak on the sand side?
Oh, I'm happy that's what you asked about. I would,
Yeah.
Yeah.
Okay.
I was like, oh, I have something to talk to Isaac about too. And
Uh,
Yeah, the sneaks. Yeah, so peak on the send side, all I really mean by that is like, okay, so right now we have a peak that's implemented as a receive, and all it's going to do is tell me about sends on a particular channel. And so I was thinking, like, why do we have that asymmetry, and why not have the analogous concept, but on the send side? So why can't I have something like a peak that I implement as a send, and it's basically going to somehow see receives on one particular channel, or maybe like several channels, because you can have your joins in your receives, and then just tell me something about the receives that I have on a given channel or set of channels.
Oh, I see.
That was kind of my thinking, is like we have this construct for peak, and it's like a receive, and it tells me something about sends, and why don't we have the same construct telling me something about receives?
So how do you detect this peak on send? How this peak gives you some information? I mean, where? On the receive side, I see you have this extra continuation without consuming anything, right?
Yeah.
This is how I see you are using this peak for some purposes for this read.
Right.
And on the send side, how you extract this peak?
Yeah. So with peak, it's just gonna find a send on the channel that you want to peak on, and then basically you've provided some continuation, and then it fills in the information in that continuation, and you execute that process in the continuation for the usual peak, right? And so I was just like I said, thinking of something similar for interacting with receives. And so the way that I was thinking of doing it was just taking the continuation from that receive, and then doing something with that continuation. So kind of like the way that a receive has a continuation. I guess this would almost be like a continuation on a send, but not quite.
Yeah.
So, hey, Isaac, do you have a text editor where you can show a snippet, or otherwise, do you mind if I show a snippet and make sure I understand the reduction?
Yeah, I don't. I'm on my phone right now, so I don't, unfortunately. But yeah, if you want to show something, that would be great.
Yeah, cool. I totally do.
Joshi, you said that now we have peak. How do you mean now we have peak? I was
said that?
They're still developing it. It's in part of cost accounting. So in the next 2 weeks, it'll be implemented. As far as
it's still not released, right?
Correct.
Yeah. So Josh, you mean on this peak that is like defined, but it's still not implemented?
Well, I'm not sure where you're referencing me talking.
I remember your message that you said a peak that we already have. And I was confused.
Oh, yeah.
The
one that we know and love, that we've thought about. Yeah, not that necessarily has a.
Okay.
Well, we have it in Isaac's K-framework implementation.
Yeah.
Yeah.
I don't have any cost accounting, but yeah, I do have peak.
Yeah. Okay.
I didn't know about this new syntax with double arrow.
Oh yeah.
I was just
I don't think that's the syntax that's in the spec document, but I mean, that's what Greg said at one point in time offhand, and apparently that's what's going now.
For me, it somehow makes sense,
It makes sense to have the syntax the way that it is now with the two arrows.
Yeah.
Oh, okay.
Oh,
I
that's,
didn't know
that's
this
great.
about new syntax, but yeah, it's.
Oh, I thought
You
it
get-
made sense with the bang because it's I don't know, doing something with sends. I guess you're peaking on sends, but I don't know. You can, make notation make sense. I guess.
Yeah. I also like the one with the bang, but if I'm totally honest with myself, I think it's just because it's like gained brain space over the last several months. Like I got.
Oh yeah. Well,
I
I'll
don't think
tell
I have
you
a
a very concrete reason why I don't like the new syntax. It's because it's 3 characters and all of the other ones are 2 characters, and I take a little bit of issue with that, but it's
All right.
okay.
Yeah, I'm gonna follow your lead then, Isaac. Okay, so there's some regular, like some process, and then it's whoops. Let's just reduce it with a down arrow. So we send and we sort of like peek at this thing. So that's gonna reduce to, it didn't consume the send because it was a peak, and then the continuation runs. Okay.
Yep.
So let me scroll that up a little bit first. So then here's a sneak. Are you spelling it like that?
I mean, I haven't really settled on anything in particular. There's no implementation for it yet, so it's all up in the air.
Okay. I'm hearing that that's as good as anything, so I'm gonna.
Yeah, exactly. Why not?
Okay. So what syntax do you want to recommend? Because I have to type it on the what used to be the send.
What was I doing? Let's just do like a question mark or something. I know that's the send notation or
that's the receive
notation in PyCalc, but we can't do a bang question mark because that already has a meaning. You can't do a question mark bang, that already has a meaning. So 2 question marks. I don't know. Just
there we go. I invented this one. It's got $1
okay.
in it.
Cool. All right.
And then we have a regular old like normal continuation here.
Mm-hmm.
And so then this one would reduce to.
And running in parallel, I'm assuming.
Oh yeah.
Yep.
So now the send is kind of like saying, peeking at the continuation, I guess, right? It's like saying, go ahead and send this, but like don't consume the 4.
Yeah.
So that would reduce to 4 whatever from Chan.
Yeah, that all just stays.
Oh, with P.
With P.
Yeah, with P. Right. Yeah, and I was thinking of even going further and saying like you provide some context to run the continuation in, and maybe even some messages to substitute in there to do some pattern matching on like, so you have, so the 4 that you've put in here is like literally any single process that runs on channel Chan would be matched and we would be fine, but maybe you want to look for receives that have like more specific pattern matching.
You're saying like here we can specify something about
yes.
4.
Yeah.
Oh, that seems like something that would be interesting to look at in terms of like how much expressivity do we gain there, or does that somehow need like synchrony? I don't know. Somehow that got me thinking, like the same part of my brain that thinks about like continuations on sends, but maybe that's not relevant here.
Yeah.
Or maybe that's not that much different than like an input guard.
Mm-hmm.
Because we could do like something like this. So maybe we could do like, well, what kind of things would you specify here though? Like behavioral properties about P?
Well, so like, I don't know. So for example, if you're expecting to find a receive on some channel that, listens for some particular pattern and you expect it to have a particular continuation, then maybe you want to be able to like execute that continuation in some controlled environment that you provide before actually like just doing a traditional send and actually consuming it, and then just like going from that point.
Yeah. So I looked at your example and I couldn't quite get it from the example, but now that you're talking about it, are you thinking something like maybe I'm sending not only this value,
Yeah.
in context, and then it reduces to like K of P.
K of P. Yeah.
Okay,
Yeah.
yeah, that's cool.
Yeah. And yeah, even more so like if your receive has, like a variable that it's listening for, then 5 would be substituted for that variable as well, or, add 5 or whatever.
Oh yeah, right. Oh yeah, because I changed the top and didn't change the bottom. Yeah.
Yeah, so if that was like P of X, now it's P of at 5 or whatever.
Yeah. How do you do that again? Just like this?
Yeah, you could do it with the curlies and do a slash X, or, I don't know. I mean, it
Oh
doesn't
yeah.
so
That's
much.
what I was looking for. That's what I was looking for, right?
Other way
Other
though,
way.
you want to substitute that 5 for the X,
Yeah. Okay.
but it's more or less the same
Yeah.
thing.
Like that.
That's it. Yeah, exactly.
Yeah, cool. Yeah, I dig that idea for sure.
Yeah, so I like your question about like how much does that afford us any more expressivity, and I don't know the answer to that question whatsoever. This was kind of just like in a daydreaming state. I was like, why don't we have this? Why do we have it for receives, and why don't we have it for this? And there may be something there about synchrony, but I'm not sure.
Yeah.
Because like I don't know, the way that I think about it is like these sends and receives are just like specifically flagged things in some collection that we are all making sure is the same essentially. And why can't we just like pick the data out of that and essentially just use it in a different way, So like it may not map directly or faithfully onto the notion of a send currently. But I guess so my proposal is like, why not a new construct that does this particular thing that basically allows you to peek on receives? Yeah, so I don't know of like I didn't have a use case in mind or anything like that. And I don't know if thinking about it and hearing about this idea, anybody has any use cases that they would be interested in. But like I was saying is, if we have some way to go and look at all of these sends on a particular channel, why don't we have a way to go and look at receives on a particular channel is kind of my thinking.
It sounds like a classic case of noticing an asymmetry and saying, whoa, I wonder what would happen if we made that symmetric.
Yeah, right. Yeah, it seems like it would be useful to know who's trying to communicate with you, I guess.
Yeah. It definitely makes sense now.
Oh yeah, cool. All right, good. Yeah, no, and the notation is kind of ridiculous because, like I said, if we're doing this for listening, if we're doing this like peek on receives, we have joins for receives. We don't have joins for sends, so it's like a more complicated issue. And so what I was thinking is, if you wanted to, sneak on a receive that's a join, and maybe it's listening on like, say 5 different channels or something, you would provide it like a list, but really that list would just be like a set or a multi-set or whatever. I guess a multi-set would be more appropriate. And it would just be like a multi-set of those 5 channels. And then, you can make your specifications for like what's, message structures you want or patterns you're hoping for this receive to listen on these different 5 channels, and then provide that context and everything. Yeah, so basically it just seemed like it would be fun to try and implement. and so I wanted to do it. But yeah, I don't have anything written up in this direction yet, because mostly I've been focusing on real things, I guess. Did anybody else have anything they wanted to talk about at this time?
I was watching this algebraic graphs.
Oh yeah, cool.
From this guy, Andre. And I was trying to compare it with Greg's top graph language. They have some similarities, and now that Dan already had implementation for Greg's version, it's much easier to compare.
Yeah.
In these algebraic graphs, they have two different monoids with the same, like a zero, with the same neutral element, and they have some distributive relation between these two monoids. This is somehow this is very similar to what Greg was explaining to us, right? In calculus lectures. He was talking about this different two different monoids and the ladle between, right?
Yeah.
But I'm still not sure how this is done in their version.
Did you try to maybe express this in Haskell and compare that way?
Not yet. Yeah.
Yeah, because that would be like maybe good approach to take a look and try to express all the because with the alga, the Haskell stuff that Andrei Markov has done, he implemented some algorithms. I was wondering if it would be possible to translate it into the model that Greg was proposing.
They have some examples which would be interesting to re-implement in both of the languages. So the other differences is Andre still in this talk he talks about labels on edges. They still don't have like definition for labels on edges or how to put the labels on edges. And in Greg's representation, Greg was saying that you can easily add labels. So, and also one thing about disjoint, when you have in Alga they call this overlay when you have when you're combining two graphs. And in Alga they say they don't have to be disjoint. I'm not sure the vertices should not be disjoint, and in Greg case they must be disjoint. But they're not the same because Greg has variables. So,
but the approach that Greg was explaining is not implemented yet, right? In a library or something.
No. Only this Idris, like Idris implementation of, but not the complete implementation.
Do you have an like idea how to, Tomislav, how to attack this problem? How to I don't know, maybe do something. Implement Haskell. Because I'm very new to this collaborative learning community, so I don't know. Maybe it would be like useful to go through, for example, paper from Andrei and somehow compare this. But I don't know. Do we need to like schedule some meeting or something?
Yeah, sure. So for me, I'm on vacation for the next 2 weeks, so I will definitely start at the beginning of August. So, but I will reading on vacation.
You are a hardcore, reading hardcore math at vacation, but
but in private, this is like a big deal.
Yeah. So do you think that it would be like useful to schedule a meeting when you go back from vacation?
Yeah, definitely. Yeah. And I want to use this dance Idris example because he's using this implementation is very nice. It's almost the same as mathematical definition by Greg's was given. You know? He's using syntax expressions of Idris, so he can exactly write what he wants. You know, g of x and v, and that's the recursive like graph expression of x and v. So it looks very nice.
Are you guys talking to Dan tomorrow morning about that?
Well, he said that he has some conflicting.
Oh yeah, that's right. I saw that. Yeah.
That time, so I'm not sure. I will ask him. Last
Is
time
that when his office hours are or something?
Yeah, tomorrow.
Oh, okay.
That used to be like an official R-Chain thing, but now that Dan's not there anymore, I think it's more of a hobby thing. But it seems like if people express interest with enough notice for him to see it, he's still super down to do them on Saturday.
Cool.
Okay.
Yeah.
But you got to let him know now because sometimes he just won't show up otherwise.
Yeah.
But Tomislav, you are not available tomorrow, right? Because you are on vacation, or I misunderstand something.
Sorry.
Tomislav, you are available tomorrow on this office hours?
Yeah, if Dan can, I will attend. Yeah.
Okay.
Yeah.
Because I thought that you write down on a Discord that you are not available because you are on vacation or something.
That was for yesterday or day before yesterday. Yeah. Dan was asking this day on the same day. Yeah. This day I was on the hiking and I was totally exhausted. So yeah.
Nice. All right, gang. Well, I'm gonna jump out. Good catching up with everybody again.
Yeah. Very nice talk about consensus.
See you, Joshi.
See you, Joshi.
So I've been reading about K-Framework a little bit more recently, and they had a paper come out sometime this year about something they call all-path reachability logic, and their thinking is so they've had this result for a while in this thing they called one-path reachability logic, which is kind of like reasoning about single transitions in a transition system. And this all-path reachability logic is about specifically in a concurrent system or non-deterministic, where you have many transitions coming out of a single state. How you can make claims or prove claims about being able. So how you can prove claims about transitions out of along all of the paths that come out of a particular state. So I've just recently started looking into it, but it seems really cool. So I'm gonna dig in deeper to that, and then hopefully if you guys are interested, we can talk a little bit about this. But I had never heard of something called the reachability system before, and they're using this reachability system idea so they derive a proof system. So their whole idea is basically like, how can we make the specification prover as general as possible so that it's no longer even language specific. And so their idea is like, so all of K-Framework, the idea is like, you want to model your programming language as a state, basically, and a state that can transition, of course. And then your syntax somehow like constrains the possible configuration states, and then like your rewrite rules basically tell it what the transitions are.
Yeah.
And so to make it language independent, they develop this formal proof system where you can do this proof like regardless of what the input syntax is and regardless of what the transitions are. Just the mere existence of these things is more than enough, and then we can start talking about this particular proof system. Yeah, so it seems really cool and really powerful, but I'm not familiar enough with like all the really formal ideas that they're using, because their main ingredient in all of this stuff is their matching logic, which is like their logic of patterns basically.
I remember this reachability mentioned with modal logic, right? You have reachability from one world to another world, right?
Yeah.
And they're proving some properties in that way that you can say that from this world this is reachable or not reachable.
Yeah, exactly. So they have a binary relation that's like an arrow. It's basically like a transition, but it's like given some certain valuation, and like depending on the model that you're working with and all of this stuff, you have these specific transitions, or you have this specific relation between these patterns, and then you can use this matching logic somehow with these patterns to try and say like what an appropriate like precondition and postcondition are whatever. And
can you say something about this match?
Yeah, and so this maybe well, I just wanted to make a connection with the modal logic stuff. So this binary relation between these patterns would be like a modal logic operator. It'd be like a diamond operator, basically. Like there exists some transition from this state to this state. And so the patterns that they think of are basically these configurations. So like to make it really concrete, like the rolling implementation that I have is like the configuration is basically just it's like that K cell that can split into many K cells, and that's basically just like your individual threads or tasks or whatever. And then it has like a send cell where all the send information goes, receive cell where all the receives go. And then I have, some other things that basically don't really affect the state whatsoever, just like what was the original first program and like that sort of stuff. But their patterns can be this configuration, which I basically set up like the allowable shape of configuration. And then it's just like, now you can fill it with variables in these particular, positions that you've created within your configuration. And then we can go and ask questions about like, okay, with this particular pattern, is it now possible to reach some other given pattern? And so the idea is like, if I want to prove a kind of, say like fairness property, where like if I have two sends in the tuple space and one receive all on the same channel, and I want to, prove something like, it's always the case that I can consume either one of those. Like it doesn't always, consume the same one or something along those lines. I can make my initial state, like exactly what you would think, like those two sends and that one receive in the right place in the configuration, and then make the final state, something where it's like, well, one got consumed, and I can also make another one where it's like the other one got consumed, and just make sure that both of those states are reachable from the original state, if that makes sense.
Yeah.
So that's how the behavioral or like the dynamic properties are proved in K framework. That's how their kprove command works and their specification.
I see. In your implementation now, you have almost something like that, right? You have the rules, semantic rules, right? And
yep.
If you write something like send, two sends and receive, you will see in your result, like all of the reductions, right? In one pattern, another pattern. But you are saying you want some kind of another language to talk about these different paths of reductions, right?
Well, so here's the really nice thing about K-Framework, and I didn't understand this at first, and I'm starting to understand how nice K-Framework actually is, because I'm seeing all these other tools like TLA Plus, which basically only allows you to do like specification on the design level, not on the actual language level. But K-Framework allows you to do both of them right in the same tool. Because you define the language and the syntax and the semantics and everything formally. You have a formal model of it. You can then run specifications on the code itself, and it has a tool to do that. But it also has this tool to prove behaviors about your programming language as well. Like given so they totally sidestep all of this Hoare logic and like axiomatic semantics business by using this matching logic and reachability logic.
So it could be possible to translate TLI plus models into K-Framework easily?
Well, okay, easily I don't know, but yes, it should be possible to do that. As far as I know, it should be possible to write any language in K-Framework, or at least that's the hope and the dream.
Two things. First of all, the reachability. I believe that I've recently looked at the talk by Mike Stay about LADL. It's from Airchain Retreat. And he was talking about reachability.
Yeah.
But
right.
I'm like trying to fit into my head. I don't understand this thing. I can link a video.
I think I've seen it. It's been a while. I should probably watch it again.
It's from 2017.
Yeah, their ladle is really, really interesting, because they are, how does ladle work? You can essentially generate, dang it, I don't know why I always forget this. You can basically generate, what is it, a logic from,
if you have semantics right and collection, you can generate a type system.
Generate a type system. Okay.
If you have notions of collection and semantic rules.
Okay.
Right.
That was a mention because I find this connection in my mind, but I don't know if it's related to what you are talking at, Isaac, or the second thing was, are you following K-Framework documentation or some paper, or you are doing your own research with this idea?
So the documentation is not great for K-Framework, but they have all of their publications on their website. So like they have tons and tons of papers, at least, that you can read. Unfortunately, for learning how to use the tool, the papers aren't the most helpful sometimes, because they did something which is really cool, I think, in hindsight, but also makes it a little bit hard to learn about the actual tool that they built. And they basically started writing papers about these ideas 10 or 15 years ago. And then as they were building the tool and like refining the ideas, they just released more and more papers, kind of like, going back and like, maybe not correcting things, but elaborating on things and saying like, okay, now we have a proof of this particular claim that we wanted a proof of in this previous paper or something like that. So you can kind of see the evolution of the ideas, which is cool, but it also makes it really difficult to say like, oh yeah, this is the paper that you need to read to really understand how to like work with this tool, But but they do have some primer papers and like introduction to K framework papers, and those ones are in general good.
Do you recommend this video tutorial about Grigori or so?
Yes, absolutely. That's a really good tutorial, and I found it really hard to follow at first. But again, it's one of those things that, like, after you do it and suffer a little bit, everything starts to fall into place, and it all starts to make sense.
Okay, I will try to like attack this video tutorial to like understand more what you are talking.
Yeah, and Jim told me that I should start a K framework channel in Colab, so I'll do that at some point in time too. And then if you have questions or just want to talk about any of this stuff, like we'll have a designated place to do that too.
Nice idea.
Yeah.
Tomislav, you understand this LIDL idea like a lot?
Well, I'm more repeating what Greg was saying. Yeah, but I know only part of it. I know this. You have this distribution between two different models.
Okay.
But how can you generate type system for with all these pieces? Yeah, I'm not completely clear.
Yeah, what I remember is that lists are not a good collection, but sets are a good collection.
or multi-sets, right?
Yeah, or multi-sets.
I was starting to like multi-sets. They're cool.
You said you're just starting to like them?
Yeah. But I don't like ordering, you know.
Well, yeah, then the multi-set is for you.
but again, implementation implies ordering. That's some kind of problem, you know.
Yeah, right.
And in Dan's implementation for graphs in Idris, he's using proof, but he's not using some kind of map, and he's using like a list of pairs. So he don't have to order keys, because he just enumerate, you know, all the existing all existing elements in the list, and then you can find the key. You know, he has the key, or if he cannot find, you know, he can add new one. But in a sense, I was thinking that if you don't have ordering, you pay somehow, right? You're enumerating all the elements of the list because you don't have ordering.
Right.
So
yeah, how do you search your elements if they're not ordered in any way?
Yeah. And somehow this is like related to consensus, you know. In a sense that you must have this notion of ordering if you want to.
Oh yeah, you mean just like an analogy with you must have some sort of like transaction ordering to be able to come to consensus about the history or whatever. Yeah,
and maybe not the ordering of all of the elements. Maybe some subset, but between this subset, you order something.
Yeah, I mean, I think it makes sense too, though, because like, you know, in a transaction or like blockchain setting, it makes sense that there has to be some kind of ordering because there are causal connections between these things, right?
Yeah,
and that makes me wonder, like, are there some implicit causal connections between something in the implementation that maybe you can get around? I don't know how that would be possible, but
I was thinking exactly the same. Yeah.
Yeah.
Why do I need to specify so ordering? We have like a causal relation, right? That we can use to have this order.
Yeah.
Yeah.
Yeah, it's interesting. I guess that would like get into the computer architecture, though, like how you're actually. Well, I don't know. Is it a hardware or a purely software thing? Why we have to order?
I'm wondering what Greg.
Data.
Yeah, I'm wondering what Greg is thinking with this error correcting codes. On last two Caspers, he was talking about. I mixed everything, so.
Yeah, I hear you.
But it's super interesting, how I was thinking this relation between error correcting codes and you are sending multiple messages, right, to create some kind of synchronous constraint. Mm-hmm. And this synchronous constraint is somehow ordering, right?
Yeah. So when we say a synchrony constraint, like what specifically, is there an example you can give me by what we mean by synchrony constraint? Like if I don't know, do some particular action and like, I don't know, I want a synchrony constraint to be like this other action can only happen after I do the one that I just did. I guess I'm not 100% sure how to make synchrony constraints concrete, because I think synchrony like asynchronous and synchronous like pi calculus or something along those lines.
Oh yeah, I in my mind I'm I have this multiple messages. What Greg was explaining, you have more than one state that you want to make a consensus or transition to something that you want, right? And if you send only one message, it is not clear what is the final state. It can be multiple states. Mm-hmm. But if all the participants send multiple messages, like a minimum one, you're searching for minimum. You can be sure what they are exactly finalized. And this is like a synchronous constraint, right? Because you must send something and wait to receive something, and then send something, and then wait, and then send. I mean, you can optimize some of these messages, right?
Yeah.
But you must receive it. You must say, or you will say, I have fixed time slots, and you must send messages in this time slot. Or what Greg was saying, you spend something. You have some kind of fuel. Right? Mm-hmm. You send 2 messages, and you cannot send more because this is not allowed in protocol.
Yeah.
So this is how I see this synchronous constraint.
Yeah, I guess that makes sense. Like you would need a send and a receive from everybody, I guess, to know that you're all synchronized, right? Like to have something to agree on, I guess, and then make sure that everybody agrees on it. You would have to know those 2 pieces of information to know that you're synchronized.
Yeah, and if you receive messages from everyone and everyone receive messages from everyone, this is like a voting, right?
Yeah.
But this is like the best consensus, but it's less performant. So. Yeah, if you're spending some kind of fuel for each synchronization, maybe in this situation you can specify this protocol. You know that you are able only to send 2 messages, not 50 messages, and you will receive only some of the messages. So
Yeah.
I'm not completely sure. Like more complicated situations.
Mm-hmm.
But I think something else. He was talking about something else also. Yeah, I wanted to ask Jim about how this relates to some quantum system. Oh, Jim is pretty tired.
So
But
wait,
you know what I think. If one validator, one node is this is like I'm not sure how to characterize. You know, it's one system. It's a closed system. It has its own state, and each node try to synchronize with all the others, and you know. So, what does it mean to you know do the same thing as isolate one electron? You know, for a quantum computation. You know, you want to see only one electron without interacting with anything else. You know, in a sense, you want to exclude only one R node, and you know, without making consensus to anyone else. You know, because you want to know how it works. So don't tell me when you're finalized something, you know, with consensus to others. You know, when you measure. When you put a measurement, you know, you want to inspect how do you make these transitions between consensus, you know, how your internals is working.
Yeah. Well, that kind of reminds me of like quantum computing. You know, you want to sufficiently isolate these entangled qubits or whatever so that they don't interact with anything else, so you can do your computations. You know, but obviously that poses so many like physical like issues and problems. Now it just makes me wonder what entangled validators would be.
Yeah. or we are creating entangled validators.
But right? What's an anti-validator?
Yeah. and also when you have more than one qubit, right? I'm not sure how this works, but I imagine that you are building on this unstable state. On top of this unstable state, you're building another unstable state, like you know,
like a house of cards.
House of cards, yeah. And in the context of Arnold, what are you trying to do? You're not making consensus. You're somehow you know. Pushing this node to build on the other node, but without making consensus, right? They're in some kind of strange situation.
Oh, interesting. So without consensus, so that second validator is not participating in like determining whether or not those transactions or whatever were correct or valid. They just assume kind of as canonical and built on top of it.
Yeah. Well, I'm not sure how you calculate with the qubits, but I was reading that you have when you have more qubits, like it's exponentially harder to keep them in the stable position. Right? An error in one, instability in one, and error in one greatly, you know. Influence the others. So.
Yeah, there's like really big error propagation.
Yeah, and they have some clever tricks to fix these errors. But maybe we can simulate this with nodes.
Yeah, wow, it's so interesting how many analogies to nature there are in the R-chain space. You know, because Greg was talking about validators as biological entities and, you know, undergoing like apoptosis and all of this stuff, and these error correcting codes, and, you know, talking about this stuff like a chemical abstract machine, and talking about executing Rolang programs as like a chemical reaction with reaction rates and everything, and all of this stuff with like it's so cool.
yeah And in this graph language, this is also like visible, this kind of way of or style of definitions.
You said that Dan is doing that in Idris, right?
Yeah, he already done it. It's
okay.
Complete with like the whole implementation of everything, but the whole paper, I think it's.
Yeah, cool. Yeah, because I have zero exposure to Idris, but I would like to get some more exposure to these different. So what is Idris? Do you know much about it? I know it's a purely functional language, and it allows you to do like some formal like theorem proving stuff, right?
Yeah, and then the main thing it's dependently typed.
Yeah, dependent types.
Independently types. Okay, cool.
Yeah. So, in a sense, it's similar to Rolang. You can depend. Your types can contain values. So, in that sense, you have execution on the type level. So, unlike Haskell, in Idris, you can specify what is the total and what is not. Because on the type level, you want to have total functions. Because you want to be sure that compiler will be done.
Oh, okay. You're just saying total function as opposed to partial function? Yeah. Okay.
Yeah, Dan said he wants to take a look at that eventually, in a group learning session.
Yeah.
And he tried to start it one time, and people couldn't attend at that time, I think. But yeah, it's very interesting. I'm new to dependent types, but I've started looking at intro videos about it, and it's quite intriguing, considering all we're doing with RChain right now and Rolang.
Mm-hmm.
Yeah, I think that Idris is very interesting also because it has implemented linear types. They call it uniqueness types, something like that. And they are super awesome. Most functional programming languages like try to do this. For example, there are those guys who try to do this in Haskell. But in Idris it just is there. I believe they have also thing called code data.
Dan was showing this last Saturday. Yeah, I didn't know that they have.
I need to watch this video, but there's so many things to watch,
You need 3 hours.
3 millennia.
Yeah, that's the problem. I was watching one vid. I've made like 8 minutes there. It's like 2 hours talk, and I'm trying to understand this. No, I'm stopping.
Yeah, if you're just talking about watching the content, that's one thing. But if you actually want to understand the content, that's a whole other story.
I was wondering to maybe make notes from a couple of talks that caught my interest with links to papers, definitions, stuff like that. To I don't know if it would be like useful or for someone else. For me, that's how I learn. Like, make notes.
I think definitely people will find that useful, and even if it's not like immediately, if you leave those breadcrumbs, like people will find them.
Do you have some like ideas how to do this? First of all, there's something like RChain wiki. Maybe this is place, but maybe I can do this like in GitHub repo, because those are stuff that I'm learning, and I believe that when you learn something, it's a good idea to make notes, because then you know what stuff is hard. When you learn something, it's super hard to explain this when you already know this.
Mm-hmm.
But it's not easy to take notes also.
Sorry, it's not.
It's not easy to take notes. If you're learning something new,
it's hard to find any connection, in head between the stuff that you're hearing and anything else that you know.
On some of those really deep videos that come out of our chain, like that Greg does, often I use this service. There's a transcripting service that does a real good job. Trying to think of the name of it. It'll come to me. But anyway, it produces a real nice presentation and attributes the different speakers, their names, and it uses AI to, once you tell it, okay, this is Peter, then from then on it labels Peter's, conversation with it. It's real good. Jim, what's the name of that? It slipped my mind.
Yeah, you posted some of these archives, right?
Yes. Anyway, I'll find it and put it in the channel. But that way I can go over it, line by line, and look at it in a completely different way. It's free, and you get a web page devoted to whatever audio or video you're documenting.
Oh, that's cool.
Yeah, that's cool. And can you edit this? Because I would like to add a lot of not a lot, but links to Wikipedia definitions.
Yeah, you can. No, you can. Anybody can use it once I find the name of it. Otter AI, OTTER.ai. Very easy to use, and we could even do these sessions. I haven't felt compelled to do any of ours yet, but sessions that have come out of these meetings, I've ended up recording and transcribing that way.
Yeah, because it's easier to find something in internet in the text form than in a video.
Oh man, I have spent so much time rewinding our chain videos, you can't believe. Yeah. We need to set it up where our chain videos are just automatically transcribed, and that can be done. It's just one more thing to do.
Two questions I have. One is list of the topics that are interested for this Colab community, because you guys usually talk about, from what I've been here, about K framework, graphs. Yeah, that was the topics that happened. But is there a list of? Can you give me a brief overview of the stuff that you like to talk about in these meetings?
Well, for me personally, I like to talk about what I'm interested in, and fortunately, the things I happen to be interested in are shared by many of the people in this group. So I would say, if you're interested in something related to any of these areas, just run it by us, in a Discord channel or anytime here, and chances are you'll find somebody that's interested in the type of things you're looking at. I learn really well. I learn and teach the best when I'm learning and teaching. When I'm learning something, that's the best time I can teach it. you know, and I feel like it's the same way with everybody. Watching other people learn is, I mean, it's you know, I don't know, it starts happening in everybody. Everybody starts experiencing these same, you know, aha moments. And so this group learning is great stuff.
Yeah.
I gotta go, but the Big Life meeting now.
I have to go as well. This is fun. You know, bring your friends and tell them where you got it. Okay, I gotta go.
I think Gary and I are still trying to wrap our heads around in how to do consensus with the error correcting codes. That's something we want to. We hope to wrap our heads around sometime.
Yeah, that's a big one for me. The ECC and its approach and consensus finality. But I got to run.
Cool. And Gary, for the next time, you can talk about yeah.